Hi everyone, Mrs. Levenzeller here, and we're going to look at some right triangle trigonometry. For trig class, this is learning target 1F. I can find the values of trigonometric ratios for acute angles of right triangles. It's a lot of words, a lot of geometry words in there, but I bet you can break that apart. And we are going to use SOHCAHTOA. That might be the term that's more familiar to you. So right triangle trigonometry refers to SOHCAHTOA. And we're only going to do it with acute angles. When we look at obtuse angles and different types of triangles, sometimes we have to use law of sines and law of cosines, and we just want to stick with right triangles right now, so we can use the sine, cosine, and tangent. Okay, so just a refresher, SOH represents the function sine. Sine is a function now, so you should have a calculator button, a button on your calculator that says SIN. We can find the sine of certain numbers, and that's what we're going to be using here. And in order to find the ratio that helps us find the sine of an angle in a right triangle, we need to know from the particular angle you're looking at, so in our case x here, which side is opposite that angle and which side is the hypotenuse. So when you set up the ratio for sine, it's always sine of your angle. Let me get rid of this here. Sorry. It's the sine of your angle. So your angle is what goes in the parentheses in the function. And the sine is equal to, the sine of that angle is equal to the side that's opposite that angle and the side that is the hypotenuse of the triangle. So if we look below at our triangle here, we are looking at angle x, right? That's the angle that has been designated for sine. So in order to set up our ratio, we would say the sine of x is equal to, well, the side opposite x would be 5. So opposite is the numerator, and the hypotenuse of this triangle is 13. So 5/13, okay? You might have seen some places they'll convert that into a decimal. So you might see the ratio written as the sine of x is equal to 5 divided by 13, which is 0.385. So that's one way we could utilize that function. And then if we wanted to know the angle, that's where your inverse function comes. So on your calculator, let's pull up a calculator here and I'll show you. So let's say we did 5 divided by 13, okay? And then instead of hitting regular sine, we're going to hit the second or the shift button. So in our case, it's the up arrow, and sine inverse. And it tells me that this angle is 22.6 degrees. So this angle x here is 22.6 degrees, okay? Which is really good information for me because if I know two angles in a triangle, then I could go and find the third, all right? So, and different calculators will have different format for how you want to find that, but that's one of the ways. Cosine is another trig function we can use to find missing angles and missing sides in triangles. And I should note, you're not always looking for the angle. Sometimes you have an angle and you're looking for a side. But anytime you only need to solve for one of these components, the angle and or one of the sides, you can use these trig functions. So CA is the next abbreviation in SOHCAHTOA. CA is representing the function cosine, and cosine of your angle, let's get a different color here, cosine of your angle is equal to the adjacent side over the hypotenuse. Adjacent just means next to. That's all that's referring to. So if we reference our triangle over here again, we're still looking at the same angle x. The side adjacent to angle x would be 12, right? 13 is technically also adjacent, but it's the hypotenuse, so we wouldn't give it two different names there. So when I'm setting up the function for cosine, it would be the cosine of x, that's my angle I'm referencing, and then the side adjacent to angle x is 12, and the side, the hypotenuse is going to be 13. Okay, so again, if I wanted to know what is angle X, we're using the inverse function, inputting 12/13, and it gives us X, right? I'm going to pull up a different calculator, graphing calculator, so you can see what that looks like. So here, we're going to do second cosine of 12 divided by 13 and hit enter. Oh, I'm in the wrong mode, sorry. Degree mode. Okay, let me try that again. That was a bad example. Second cosine of 12 divided by 13. Oh, okay. So it should be 22.6, the same thing that we got. I just am in the wrong mode and I'm not good at that calculator at the moment, but I'll show you on here. It is good to know though that your calculator, what mode it's in. So if you see at the top of my calculator here, it says DEG. That stands for degree. The other calculator was in radian mode, which we're going to learn a lot about radians this year. And that's why it was giving me a different value. So we want degree mode when we're working with degrees. But look, I have the same answer as I got from the sine function, which is good because it's the same angle, right? We want it to be the same. So if you're good with your calculator, X should be 22.6 degrees. And lastly is the tangent. So here, the tangent of X, tangent of our angle, is equal to the side opposite divided by the adjacent side. So our tangent of X is going to be equal to the opposite side, which is 5, divided by the adjacent side, which is 12. Again, let's go take a look at our calculator. If I do 5 divided by 12, I get this decimal, and then second and tangent, again, I get 22.6, right? It's the same angle that we're working from, so when we take the inverse function, we should get, the same value every time. And you don't have to do all three of these every time. You usually want to pick one to help you solve, and that's why we have 3 of them actually, because sometimes you're given certain information in a triangle and sometimes you could only use sine or you could only use cosine. It really depends on which 2 side values you actually have, okay? So let's try just maybe 1 or 2 here. So we'll try finding the missing angle and we'll try finding the missing side. So I'm going to do number 2. So here is my reference angle, okay? And then the side they've given me here is opposite that angle. And they've also given me a side that is adjacent to that angle, right? It's not the hypotenuse. I don't have the hypotenuse. So I then need to use the function that utilizes opposite and adjacent. So let's go back and look. Well, tangent is the one that utilizes opposite over adjacent. So that's what I'm going to use to solve this problem. So the tangent of, and this little angle symbol here is called theta, is equal to the opposite side, which is 4, divided by the adjacent side, which is 13, okay? To find the inverse, I'm going to do tangent inverse of 4/13, and that should give me the angle value. We're taking the inverse function, which cancels out this regular tangent. If you remember inverses from Algebra 2, they work opposite each other, so the tangent inverse of tangent just leaves me with theta, and then we have to take the tangent inverse of the other side, okay? So 4/13, I want to get that as a decimal first, and then I did the second button already, and tangent inverse, I get 17.1. 17.1 degrees. Okay, now I can use subtraction to find the third angle, right? 90 minus 17.1 would give me angle B. And if I wanted to, I could use trig or I could use SOHCAHTOA to find the missing side length of the hypotenuse. That's how you would solve a triangle. I'm not going to go through all of that right now, but that is an option you have. Okay, The other alternative is if we are looking for a missing side length, okay? So here we have an angle given to us, an angle of 37 degrees. The side here that we're looking for is the hypotenuse. And the side over here, 11, that would be adjacent to that angle. So if we have the adjacent side and we're looking for the hypotenuse, we need to use or cosine, all right? So cosine of, remember it's always of your angle, so the cosine of 37 is equal to the adjacent side, 11, over the hypotenuse, which is x. Now, what I usually do to make this simplest on myself is I'm going to put cosine of 37 over 1, and I'm going to use cross multiplication to solve. 1 times 11 is 11. Cosine of 37 times x is x times the cosine of 37. I'm purposely leaving it as the cosine of 37 right now because I want to keep my answers exact, and if I change that into a decimal, I no longer have an exact answer, okay? I'm estimating, which can be okay for some purposes, but for right now, let's keep it exact. So if it's x times the cosine of 37 and I want to solve for x, then I need to divide by the cosine of 37, and I'm going to do that on both sides. And this is when that graphing calculator is a lot more helpful than the calculator I was using, but we'll go back to it. So on our calculator, we need to do 11 divided by the cosine of 37. Not cosine inverse, but regular cosine. So let's do that. So 11 divided by, and on this particular calculator, you have to hit 37 first and then cosine, and then equals, because we wanted to actually do that. And that gives us 13.77. So x is equal to 13.77. You want to check and make sure that makes sense. The hypotenuse has to be the longest side of the triangle, so if you got a number smaller than 11, then you're incorrect, okay? So I think those are two examples, good examples to get you started.